Hello Unity developers! How about we learn about every single component? I took an empty 3D project with a universal render pipeline template, and I will cover every component there is and that you can add on a game object. You will see that some components are dependent on other components to work. Unity always adds the required components automatically because it knows. Short disclaimer, it is going to go fast and it's going to be casual. This is not a tutorial on how to use each component, that would be madness. Alright, let's jump right into it. Transform. Every game object has one. It stores the position, rotation and scale. You can't even remove it. Now onto the first category called Mesh. Mesh filter. You put a 3D mesh inside and it will tell the mesh renderer to render it. Yes, so you need a mesh renderer. It takes the mesh from the mesh filter, also takes the transform, and with those two things it renders the mesh in the scene. Skinned mesh renderer. If you use animations or bones and want your mesh to bend and deform, you will be using a skinned mesh renderer. It's like skin, you know, it's flexible and stretches, but it never breaks. Text mesh. A mesh is 3D geometry and text is text, so text mesh is 3D text, that's all. Text Mesh Pro Text. It's text mesh on steroids. You have more options and controls over the text to make it look more awesome.
Awesome!
Next up, physics category. Rigid body. If you want the game object to react to powerful physical forces, add a rigid body. Constant force. This is the quickest way to constantly apply a force to a rigid body. That's pretty cool and you need 0 line of code.
Pretty cool.
Character controller. If you are making a 3D third or first person player and you don't like rigid bodies, you can use this as an alternative. Requires more work though. Clothes. This physically simulates fabric. You will need a mesh and the clothes component will do its thing and make it behave like a piece of clothes. Your mesh is going to deform and this means that Unity will automatically add, can you guess? A skinned mesh renderer. Use with moderation because it's expensive to compute.
Expensive.
Box collider. A collider that's the shape of a box or cuboids. It can be of any size and dimension. It does not need to be a perfect cube. It's a primitive, so super efficient.
Efficient.
Sphere collider. A collider that's the shape of a sphere. You can only change the radius. It's a perfect sphere and not a rugby ball. It's also primitive, so super efficient.
Efficient.
Capsule collider. A collider that's the shape of a capsule. It's a primitive, so super efficient.
Efficient.
Mesh collider. A collider that's the shape of a mesh. If you want it to collide with other mesh colliders, you will need to set it as convex. It's not a primitive, so less efficient.
Less efficient.
Terrain collider. If you use Unity's terrain system and want the player to walk on it, you will probably need a terrain collider. Wheel collider. A special collider. That's right, Unity describes it like that. If you want to make physically accurate wheel physics, well, this is for you. Next few components are joints. A joint connects two objects through physics and can break under enough force. Fixed joint, the simplest joint. It's like parenting an object to another, useful for easily making objects break apart. Spring joint, a joint that connects two objects as if they were attached by a spring. It's like an elastic. Hinge joint, a joint that connects two objects with a hinge. It's useful for doors, saloon doors, traps, or even chains. Character joint. A joint that connects two objects together like an extended ball socket, useful for doing ragdoll madness. Configurable joint. A joint that supports all the features of all other joints previously presented. That's for the hardcore developers.
Hardcore.
Next up is kind of the same but different. It's physics 2D. Rigid body 2D. Welcome to the 2D world. A rigid body 2D is like a rigid body, but only works on the X and Y planes. Constant force 2D. This is the quickest way to constantly apply a force to a rigid body 2D. That's pretty cool and you need 0 line of code. Box collider 2D. A collider that's the size of a 2D box, so just a rectangle. Very efficient to compute.
Efficient.
You can even have rounded corners, which is less efficient.
Less efficient.
Circle collider 2D. A collider that's the size of a circle. Very simple, very efficient.
Efficient.
Capsule collider 2D. A collider that's the size of a capsule. Ideal for characters that don't want to get stuck on edges of other colliders. Polygon collider 2D. A collider where you can define the shape using line segments. What's special is that the shape must close. Edge collider 2D. A collider where you can also define the shape using line segments, but it does not too close like the polygon collider. Composite collider 2D, a collider that has no shape. Instead, it merges all box and polygon colliders into one new shape. For this to work, you check used by composite on the other colliders. You can use all kinds of effectors to direct the forces of colliders that touch each other. An effector also needs the collider to know what's the area of effect. Buoyancy? I need to Google that. Why they don't just call this water?
Buoyancy.
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 Buoyancy. Buoyancy effector 2D. The buoyancy effector can make objects float. Area effector 2D. This effector is typically used with trigger colliders. You can set a specific force magnitude, variation, and even some drag. Surface effector 2D. They should rename this to conveyor belts. It applies a force that's tangent to the collider's surface. Point effector 2D. This effector can attract or repulse game objects. It's typically used with a trigger collider. Platform effector 2D. This effector can be used to make your character jump on a platform from under it, but not fall through from above. It makes your collider work one way only. It's kind of underrated.
Underrated.
Let's see some 2D joints now. Fixed joint 2D. Just like fixed joint for 3D, but it's 2D. Spring joint 2D. Just like the spring joint for 3D, but it's 2D. Friction joint 2D. This joint is interesting. It reduces the linear and angular velocities between the objects to 0. It's useful for simulating frictions in a top-down game. Distance joint 2D. Just like a spring joint, but the distance between two connected objects is constant. Target joint 2D. This joint is cool as well. It does not need to connect to a rigid body. It can connect to any target. It's useful for drag and drop or making a game object hang using the mouse cursor. Hinge joint 2D. It's a hinge. The joint connects two game objects together and they can rotate at the hinge. It's good for doors and stuff. Wheel joint 2D. If you make a 2D vehicle and you want wheels and suspensions, then you need this joint. Relative joint 2D. Another 2D specific joint. You can make two objects keep a specific distance and angle from each other. Sounds like a distance or fixed or spring joint, but the difference is that relative joints are motor based and not spring based. It's useful for making things follow and rotate along as the main object moves. Slider joint 2D. This joint makes the rigid body slide freely along a line. You can also enable the motor. Pretty cool for sliding doors and stuff.
Pretty cool.
Alright, navigation or nav mesh. Nav mesh agent. Put this on characters so they can find their ways around the map. Yes, it's pathfinding. Agents can also avoid each other. Do not confuse this with an actual AI. Nav mesh agents are pretty stupid. Nav mesh obstacle. When you bake the nav mesh of a scene, it's static and it's expensive to bake. If you want moving obstacles that the nav mesh agents can understand, you need to add this component to it. Off mesh link. Usually nav mesh agents find the shortest path to their destination by keeping their feet on the ground. This component allows you to make the nav mesh agent take shortcuts, like jumping over a fence or jumping down a high ground. Let's move over to audio. Audio source. It's a speaker. It can play sound and you can have tons of settings to configure it. It also supports spatial 3D sound. Connect the audio source to a mixer for even greater power. Audio listener. This is a microphone of the game. Sound goes in and plays back to your computer. It's already there on the main camera. Without it, nothing works. Most of the other sound components work based on where the audio listener is located. Audio reverb zone. Reverb is what you don't want in your home, but only in your game. When the audio listener enters this zone, which is a spherical area, some reverb is applied. You have tons of presets to simulate different types of environment. It's pretty cool.
Pretty cool.
Audio reverb filter. The same as before, but as a filter instead of a zone. This means that it is always applied, regardless of distance. Audio low pass filter. It cuts off low frequencies. Easy solution to make something sound like it's coming through a radio or a speaker. Audio high pass filter. If you can cut low frequencies, you might also want to cut off high frequencies. Audio echo filter. This is when you screamed in a tunnel as a kid and the tunnel screamed back at you. Audio distortion filter. This will simply distort the sound and make it sound like a very old radio transmitter. Audio chorus filter. This will take the sound and make it sound like it's coming from multiple sources. Oh, and the order of the filters matter. Doing low pass echo chorus is not the same as doing chorus echo and then low pass. Next category is called like and subscribe. If you enjoyed this video so far, please leave a thumbs up and be sure to subscribe for more game dev. Also, don't forget to hit the bell to get notified every time I release a new video. Alright, let's move on to effects. Particle system. Use this to spawn particles. There are tons of things to configure and endless possibilities if you are creative. Visual effect. Only works if you have also installed the VFX Graph. It's like the particle system but on steroids. Trail renderer. This component is awesome and highly underrated. It creates a trail behind a moving object. It's great for extra wind effect or adding a real feeling of speed. Line renderer. Render a custom line consisting of at least 2 points. You can do lots of stuff with this one. Projector. Project a material onto a surface. This is great for blob shadows, decals, blood splashes, bullet holes and so on. Lens flare. Use this to manually create lens flares. It takes a flare asset where you need to set up a texture in a specific way. Simpler than this, you can also put a flare asset on the light directly. To see lens flares, you need to put a flare layer on the camera. Halo. This adds a cheap bloom effect around the light source. Next up, all rendering components. Camera. That is what is used for showing something on the screen. No camera, no image. Light. Create a light of some kind. You can configure it as a point light, spotlight, directional light, which is essentially a sun, or even a real light. You can set the light as real time, baked or mixed. Yeah, have fun baking lights. Light probe group. This creates a group of light probes. Light probes are used to bake lighting information. So instead of having real-time lighting of everything, you can bake the information. A game object will light itself based on one light probe, which interprets its lighting information from nearby probes. Looks less real-time, but it's more efficient.
Efficient.
Light probe proxy volume. Light probes are good for small objects like boxes or characters, but if you have a large object where a single light probe is not enough, then you need a light probe proxy volume. Reflection probe. Accurate reflections are expensive.
Expensive.
So you put reflection probes and this will do some reflection mapping and simulate reflection from objects around. Occlusion culling is about hiding or rendering objects that will 100% not be seen on camera. Occlusion area. Usually occlusion culling is pretty rough. If you know your camera will be in a certain area at runtime, you can define an occlusion area and this will increase the precision of the occlusion culling at this place. Occlusion portal. This one is pretty cool, mostly because it's a portal. You can open or close it. Close means that it will hide objects behind, and open means it will render them. You would put this behind a door and toggle the portal based on the door's state. This is pretty cool for optimization.
Pretty cool.
LOD group. LOD stands for level of detail. The farther away an object is from the camera, the less details in the geometry you need. This component manages the fading between the different versions of your 3D mesh based on the distance to the camera. Your 3D artist will love you for this. Canvas renderer. It's a component, so I will cover it. It has no public properties, you just need it to render UI objects on a canvas. Sprite renderer. This renders a sprite. Can be used for 2D and 3D projects. Simple. Sorting group. This component basically allows you to group sprite renderers together. Skybox. Use this if you need more control over your skyboxes and if you have many cameras in your scene. This component overrides the skybox settings on the camera. Flare layer. We mentioned it briefly, you need to put this on the camera to be able to see lens flares. Streaming controller. This is a bit of heavy stuff about managing textures in memory. By default, Unity computes MIP map streaming for all cameras. So if you deactivate it, you can use this component to manually tune how textures are being loaded for each camera. I guess. I hope this is correct. Let's talk about tile maps. Tile map. You can use this to create 2D levels. You can work with rectangular tiles, isometric tiles, or even hexagonal tiles. Tile map renderer. You also need this to render tiles and tile maps, and you can configure some stuff on it. Tile map collider 2D. This component is handy. It will create the appropriate colliders to cover your entire tile map. Next up, the obscure event category. I say obscure because Unity's documentation is not the best for those components. From what I understand, all those next components are there to help you with the communication between different objects. Event system. This component is there to manage things like what game object is selected, which input module to use, and which one to update. Some raycasting and so on. It's added automatically when you create a UI. Event trigger. You can catch events and call a function for each one. Physics raycaster. This component always needs a camera and will shoot out a raycast. That raycast will send a message to the target object if that object implements the event interfaces, like iEvent system handler. I don't remember seeing this being used. Physics 2D raycaster. The same as before, just for 2D. Graphic raycaster. Again a raycaster, but for graphical UI elements. You will actually encounter this when working with canvases. Standalone input module. This component is advertised as being designed to support mouse, keyboard and controller input. It seems that the best use case is for handling navigation of UI elements, like buttons and so on, by multiple input systems. For example, you can navigate a menu by hovering with the mouse or by using arrow keys. Touch input module. It's marked as deprecated, meaning you should not use it anymore. Has this been deprecated recently? Let's see. Unity version 5.5, that's before 2017. This component is marked as obsolete. Unity just removed this already.
Deprecated.
Alright, UI components. Let's go fast over it. Text. Display text on a canvas. Text Mesh Pro text. The same, but with cooler font options. Input field, for letting the user type text. Text Mesh Pro input field, the same, but with cooler font options. Drop down, a list of options to choose from. Drop down Text Mesh Pro. What? Every Text Mesh Pro component is named Text Mesh Pro and then the name. Here it's inverted. It hurts, it just hurts. Anyway, it's a drop down with cooler font options. Slider, move a little handle between two values. Scroll bar, a scroll bar that can be horizontal or vertical. Scroll rect, you need this to make a large component scrollable. Button, click click click. Selectable, buttons and other components derive from this. I don't really think you need this, maybe if you want to do your own source. Toggle, an on-off switch, basically a checkbox. Toggle group, groups toggles together so they become radio boxes. Image, add a sprite on the UI. Raw image, add a 2D texture on the UI. You can use this to display a second camera as a minimap, for example. Shadow, add shadows to an UI element. Quite underrated.
Underrated.
Outline, add an outline to a UI element. Also underrated.
Underrated.
Rect Mask 2D. This allows you to mask an UI element. Mask. This will show the mask graphics. Position as UV1. This saves the position of the canvas as UV data. You can then use that information in some shaders and stuff. Next up, some more UI elements. Rect Transform. All UI elements are changed from Transform to Rect Transform. Canvas. That's where you put UI elements. You can have many canvases and it's better like that. Don't put all in one canvas. Canvas Group. A handy component to modify things like alpha on all the children. Also useful to optimize UI draw calls. Canvas Scaler. This manages how the canvas scales. It's very important if you plan to support many resolutions. Vertical Layout Group. Automatically organize child elements vertically. Horizontal Layout Group. The same, but horizontally. Grid Layout Group. The same, but as a grid where each cell has the same size. Layout Element. You typically add these on child elements to override certain values. Content Size Fitter. This component tries to fit content by resizing the rect transform. You put this next to a component text, image or any other layout groups. Aspect Ratio Fitter. A bit similar, but it resizes the rect transform by considering the given aspect ratio. Playables. This category has one element. Playable Director, for playing playable assets like timelines. Video. This category has also one element. A video player. This plays a video. Yep. Miscellaneous. Miscellaneous?
Miscellaneous.
Miscellaneous. The next category is called miscellaneous. It contains all kinds of things that apparently do not belong into their own category. Of course, Playable Director and Video Player are too fancy. They need their own category to be alone in it. Alright, let's cover the rest. Animator. The one and almighty component to animate game objects using Unity's mechanism system. Animation. This is a legacy system. It has less features, but might be more performant for simple objects with a single animation. Like you don't need a full state machine for one animation clip, just use this. Terrain. This renders a terrain. It's going to be set up automatically when you create a new terrain game object. Volume. This is specific to the URP project and the post-processing stack. It defines the volume to apply some post-processing. Billboard renderer. This renders a billboard asset, which is mainly used to display simpler representations of complicated meshes when they are far away from the camera. Sprite shape renderer. This renders the geometry of a spline, works for 2D and 3D. Sprite mask. Another type of mask, this one only affects sprite renderers. Grid. This component should help you define a grid and align objects to the cells as you defined. Alright, the next 6 components are kind of interesting. Position constraint. Moves a game object to follow the source game objects. Rotation constraint. Rotates a game objects the same way as the source game objects. Scale constraint. Scales a game object the same way as the source game objects. Parent constraint. You can parent objects together without having them parented in the hierarchy. Aim constraint. Rotates a game object to face another game object, but it also keeps one axis fixed. Look at constraint. Again, rotates a game object to face the source game objects, useful for cameras or even security cameras or other things. Particle system force field. A force field that you can attach to a particle system and have more controls over the particles. Wind zone. This is mainly used to realistically animate trees in the terrain system, but you can also affect particle system, which is pretty cool. Articulation body. This is a type of joint for getting more realistic physics for industrial robots and stuff. And with this, we just covered every Unity component that can be found on a clean universal render pipeline project. I hope you enjoyed this video and learned something. I definitely learned a few things. Now, I'm curious to hear from you, what's your favorite component or even your least favorite component? Just comment below what you think. With that being said, I thank you very much for watching this video. Keep it up, and I will see you next time.